Hi, my name's John Birchall. I'm one of the technical managers here at JASCO. Today I'd like to share with you some interesting new developments in the study of VHH antibodies. Unique single domain molecules, around 15 kilodaltons, were discovered about 25 years ago and are proving to be useful in applications such as environmental monitoring and therapeutics. Their small size lends themselves to binding to small molecule antigens. VHH antibodies are typically found in camelids and sharks, and their unique structure includes only the heavy binding chain rather than the heavy and the light binding chains that are found in mammalian systems. The VHH antibody binding portion can also be excised from the main molecule to create a simple nanobody. There are many advantages to the application of VHH antibodies. The small size of these antibodies means they can be used to target with very high resolution. They also lend themselves to gene amplification, which makes mass production much more straightforward. And they're proving to be extremely stable. There is a rapidly growing excitement from a range of companies around the world to develop antibody libraries using VHH antibodies. At JASCO, we have been collaborating with one of the successful companies to characterize these proteins using circular dichroism and FTIR spectroscopy. In this short video, we would like to share a few highlights of the data that we obtained using a JASCO J1500 CD spectropolarimeter using high throughput screening, thermal ramping, and spectral correlation analysis. We looked at a couple of key features of the VHH antibodies. In the first application, we used thermal ramping to study the structure of beta sheet in the protein and how it unfolds and refolds with the effects of temperature, and how the stability returned at room temperature. In the thermal ramps, we can see that comparable TMs were found in the region of 60 to 70 degrees for each of the variants. When we estimated the secondary structure, we could find the effect on the beta sheet motif during the heating and the cooling process. In each case, the structure recovered when returned to room temperature. In the second evaluation, we looked at the stability of coronavirus binding VHH antibodies by evaluating the higher order structure around the aromatic amino acid residues and the secondary structure. JASCO's newly patented correlation algorithm was used to compare spectral differences both in the far UV and the near UV to give some indication of the structural differences in the VHH antibodies. Visually, the data looks pretty similar. However, by using a weighted statistical model, it's possible to see significant differences in each of the spectra. This is just a snapshot of the data that was obtained. If you want to find out more, please come and take a look at our Learning Center at jascoinc.com/learning center.